All right, let's start off here with the general multiplication rule. So this is saying the probability of A and B. So we said probability of A or B before on 5.1. This is probability of A and B. So if I need something to happen and something else to happen, it is probability of A times probability of B given A. So the big idea here is this is multiplication. Multiplication actually usually makes, when you multiply two fractions, it actually makes it smaller, which makes sense because it's like if I need two things to happen, the probability is actually going to go down because I need the first thing to happen and the second thing to happen. It's more difficult, and so the probability is going to go down when we multiply fractions. If it's or, the probability should go up, which does happen when we add because it's like I can have the first thing happen or the second thing. Doesn't matter. Okay, so first question here, it says 5% of all athletes at a certain university are using PEDs. Unfortunately, the tests to use PEDs aren't perfect. Suppose that 3% of the athletes who are not using PEDs will test positive and be accused of using them. Meanwhile, 1% of athletes who are using PEDs will test negative. Okay, so if we want to write this in the probability notation, the first one, 5% of all athletes are using steroids. So the probability that they are using PEDs, and so that's out of all of the athletes, that's PEDs, equals 0.05. All right, and then for the next one, the 3% of those who are not using PEDs will test positive. So the probability that they test positive, but that's not out of everybody. This is given that they are not using PEDs. So not using is going to equal 3% or 0.03. Okay, and the last one is 1% of those who are using PEDs will test negative. So the probability that they test negative, given that they are using PEDs, is 1% or 0.01. Okay, so we're going to draw what's called a probability tree for this. Okay, so I'll teach you how to do this. So first of all, I'm going to build a box to start over here. And this will just be a randomly selected athlete. Okay, and then our first split is, are they using PEDs or not? And so we know that the probability that they're using PEDs is 5% or 0.05. And whenever we do one of these splits, it should always add up to 1 because those are that's the complements. So either they're using PEDs or not. So we can do 1 minus the one that I have. And then that's going to give me my answer right here. So in this case, that would be 0.95. And so you can always do that, subtract 1 from one of these branches to get you the other one. Okay, and so now I'm going to split these up. And so out of those who are using PEDs, you can test positive, or you can test negative. Okay, and that is actually the same for those who are not using. You could still test positive, or you could test negative. Okay, so we know that the probability, if they are not using and that they test positive, is the 0.03 that we had up there. And we'll do 1 minus 0.03 will give me 0.97 down there. All right, and then the probability that they test negative, given that they're using, is 0.01. So that's actually going to go right here because that is they're testing negative, but they are using the PEDs. And then so 1 minus 0.01 would be 0.99 right here, which is what it should be. So if you're using the PEDs, you should be testing positive, right? And if you're not using, the higher number is on testing negative, which is what it should be. Okay, so then there's 4 lines out here. And so how you do this is you use that multiplication rule that we said at the top. And so for each branch, we're going to multiply along the branch. So the probability that they used PEDs and tested positive is this probability that they use PEDs times the probability that they test positive given that they use PEDs. So we're just going to multiply along that branch, then we're going to multiply that way, then this way, then that way. So our first one here, we're going to do 0.05 times 0.99. So that's going to give me 0.0495. So out of everybody, that's a probability that they use PEDs and tested positive. And so you can see it's a little under 5%. So it's kind of almost everybody. So it's 5% of the school is using PEDs. So almost 5% uses the PEDs and gets caught. All right, so then the next one here, we're going to multiply 0.05 times 0.01. So this is probably the least popular out of the four, is that you're using PEDs but testing negative. So that's going to be 0.0005. And then the probability that you are not using PEDs and you test positive, that would be 0.95 times 0.03, probably pretty low here. Is 0.0285. Now that's actually not much lower than you can see this group up here, because we have so many people in this not using group that even though very few of them are testing positive, that still makes up a big population of the school, almost as much as that one. Even though this one is most of this group, it's just that this is out of a smaller group. All right, and then our last one down here is probably the biggest group. So they're not using, and then they test negative, and so this comes out to 0.9215. Okay, so next up, calculate the probability that a randomly selected athlete will test positive. Well, if they're going to test positive, it could be the ones up here that are taking the PEDs, but it could also be these that have the false positive. So I need to add those two together. So I'm going to do 0.0495 plus 0.0285, and that equals, type that in my calculator, 0.078. So about 7.8% of the school is going to test positive. Now that is some of the group that is actually using and some of the group that is not. Now if I randomly selected a player who tested positive, so if I'm only picking out of the players that tested positive, that means I'm picking out of these 0.078. That's all the people that tested positive. And then out of that group, how many were actually using PEDs? Well, this was the actually using PEDs group right here, right? The 0.0495. And so I'm going to move that there. This group was actually not using, if you look back at our chart. And so that's why I'm not going to put them in my numerator, but they were really part of the denominator if you look. And this comes out to 0.635. So actually, if we, out of all the people in the school that tested positive, only 63% of them were actually using steroids. So it's kind of weird the way we ask that, because that second group was so big, the group that's not using but tested positive, we can't be sure if someone tested positive. It's very likely here that they actually might not be using PEDs. All right, next up we have another formula right here. It's multiplication for independent events, A and B. So we said probability of A and B above was multiplication. It is still multiplication here. So probability of A is the same as it is above. The second part, though, is just going to be probability of B. If A and B are independent anyway, we don't need to worry about the B given A. So something like this, suppose Olivia is an 80% free throw shooter, and the outcome of her shots are independent. What's the probability she makes 3 free throws in a row? So this would be she makes the first one, and she makes the second one. Actually, I'll just use the multiplying dots for this. So 3 in a row. She makes the first one, and she makes the second one would be times 0.8. And she makes the third one would be times 0.8 again. So 0.8 times 0.8 times 0.8. And that comes out to 0.512. So 51.2% chance she makes 3 in a row, even though she's an 80% shooter. Now, what's the probability that she misses 3 in a row? Well, if her probability of making is 0.8, that means the probability of missing is 0.2. So I just multiply that times itself 3 times. 0.2 times 0.2 times 0.2. So that would be 0.008. So less than 1% chance, 0.8% chance. Last one here. What's the probability that she misses at least 1 out of 3 free throws? Now this one is complicated. It says at least 1 out of 3. That means like she could. You can find the probability that she makes 2, miss 1, or probability that she make 1, miss 2, or the probability that she makes 0, miss 3. So we'd have to do all of those and add them together. There's a much easier way to do it, okay? So I'm going to do it a different technique here. Let me get a different color. Let me get like a purple here. So the probability that she misses at least 1 would be 1 minus the probability that she makes all 3, because that's like the opposite of missing at least 1 is if she makes all 3. It's the complement. And so I already know the probability that she makes all 3. It's right here, that 0.512. So 1 minus 0.512 would give me 0.488, and that would be that probability.